Evaluate the expression without the use of a calculator. We have natural log the 9th root of e squared. So in this question, we want to simplify or evaluate without a calculator. So that means we'll have to know what these symbols mean and some properties of logarithms to be able to simplify. And of course, there's multiple ways that you can simplify this as well. So I'll try to take a couple different approaches so that you can understand it in different ways. So one thing to keep in mind here is that a radical can be written as a power. So having the 9th root is the same thing as raising to the 1/9 power. So this is the same thing as natural log e squared to the 1/9 power, or natural log e to the 2/9 power if you consider that squared. So then one property of logarithms we should keep in mind is the inverse property. The inverse property, we have two of them, and the reason why we have the inverse property is because natural log and e are inverses of each other, or in general, exponents and logarithms are inverses of each other. So when we compose them, those operations cancel out. So if we have log base b of b to a power, the log base b and the b to the power are inverses of each other. Those cancel and you get the power. You also have another inverse property, b to the log base b of m. So once again, the log and the exponential are inverses of each other and they cancel each other out, and you can get m. So in this example, we have natural log, which is base e, and e to a power. These are inverses of each other and they can cancel out to give you just 2/9. Now, this is not the only way you can do this problem. Another option would be to use the power rule for logarithms. The power rule is when you have a power inside the logarithm. If you have log base b of, say, x to a power, you can write that as the power times log base b of x. So another option would be for us to apply that power rule. We get 2/9 natural log of e. And then we can try to simplify natural log of e. Now natural log of e is going to equal 1. Anytime, this is another property, this property says that if log base b of b is going to equal 1, anytime the base is the same as what you're taking the log of is equal to 1. So this is 2/9 times 1, which is 2/9. So here are just a couple different ways that we work this out to be 2/9. A certain radioactive isotope has leaked into a small stream. 300 days after the leak, 3% of the original substance remained. Determine the half-life of this radioactive isotope. So this example is referring to a decaying factor using exponential decay. So let's first write out what formula we're going to be using. And that formula is A of t equals A naught e to the kt. We want to make sure we know what the components of this formula stand for. We have A naught, which is our initial amount or starting amount. We have K, which in this example will be our decay rate. And we know it's a decay rate because 3% of the original amount is remaining. So that is 3% is less than 100%, so it's decaying. And this value will be a negative value, that decay rate. Then we have our variable t. T stands for time. And the units of time need to be consistent through the problem. Here we're given 300 days, so we're going to use days as our unit of time. And then we have our final variable a, and a is going to be our amount after time, after some period of time. So we're going to plug in a time period, and we're going to know the amount remaining after that time period. So we have a goal in this problem of finding the half-life, but in order to find the half-life, we need to know the decay rate. So we're going to start by finding the decay rate and then find the half-life. So we're going to use this piece of information right here, 300 days, 3% of the original amount remains. So with a time period of 300 days, I know that 3% remains. Now this isn't a specific number, but this 3% remaining tells me how much of the original amount is left, or the relationship between our starting amount and our ending amount. So this 3% remaining tells me that I'm going to have 3% of the original amount after that 300 days. So with this information, I'm going to be able to solve for that K, the decay rate. So let's substitute this information into the formula. So here's our formula. A of t equals A naught e to the kt. A is 3% of the original amount. And we have a time of 300 days. Now we're going to start solving this equation, this exponential equation. We're going to divide both sides by A naught. And that A naught cancels on both sides. We get 0.03 equals e to the 300k. I'm going to solve this by doing the natural log on both sides. Let me make that a little bit clearer. That's natural log e to the 300k. The natural log and e are inverses of each other. They cancel and you get 300k equals natural log 0.03. We're going to divide both sides by 300 and we get our value of k to be natural log 0.03 over 300. So now we have the value of K, our decay rate. And now we're going to find the half-life, which is the question that we have. Our half-life is the time, we don't know the time it takes to decay to half. So that means we do know the relationship between A and A naught. We're going to have half of our original amount. So using the value of K we just found, the relationship between A and A naught, we're going to be able to find that half-life, the time it takes to decay to half of what we started with. So once again, let's start with our formula. A of t equals A naught e to the kt. We're looking for half-life, so we're going to have half of our starting amount. And we know the value of k is natural log of 0.03 over 300, and we're solving for time. So we're going to divide both sides by A naught to get 1/2 equals e to the natural log 0.03 over 300 t. I'm going to take the natural log of both sides. The natural log and the e cancel each other out. So we have natural log of 1/2 equals natural log 0.03 over 300 t. To solve this, I'll multiply by the reciprocal. I'll multiply by 300 over natural log 0.03 on both sides. Excuse me, I'm multiplying by the reciprocal. 300 over natural log 0.03. About 300 would cancel, natural log 0.03 will cancel, we're left with t. So we have 300 natural log 1/2 over natural log 0.03 as our time. So let's get our calculator out. We'll put this in the calculator. When you put it in the calculator, you want to make sure you put parentheses around the numerator since there's more than one thing in the numerator, and parentheses around the denominator. We really don't need the ones in the denominator. Because there's only one thing in the denominator. We have 300 parentheses 300 natural log of 0.5, that's the same thing as 1/2, over natural log 0.03. And we get 59.3. So this radioactive material has a half-life of 59.3 days. Let me zoom out so we can see an overview of what we did in this problem. So we needed to use this information that there's 3% remaining after 300 days to find the value of K. And once we found the value of K, we could find the half-life. Half-life of 59.3 days. on this example, we have a quadratic function, f of x equals x squared plus 2x minus 5. And we want to find the vertex of this parabola. The graph of a quadratic is a parabola. We want to find the orientation of that parabola, meaning does it face up or down? And we also want to find the axis of symmetry. Now this quadratic function is in our general form, or you can think of that as the expanded form. And when it's in the expanded form or general form, there are two basic methods for figuring out the vertex. One of them is to convert it to the standard form using completing the square. Our standard form would be a times x minus h squared plus k. So you can use completing the square to write it in this format. Most people, because it's a lot of steps to complete the square, don't like this method. The other way to figure out the vertex is with a formula that you memorize, the vertex formula. And the vertex is an ordered pair hk. You can find h by using the formula negative b over 2a, and you can find k by plugging that x value in to get the y. So you can do f of negative b over 2a. I can show you both methods for finding that vertex. So I'll do the harder one first, which is using completing the square. We have f of x equals x squared plus 2x minus 5. If I use completing the square, you want to factor out any coefficient you have and then group your x terms together. So we don't have a coefficient, we'll just group those x terms together. And you're only going to factor, if you do have a coefficient, you're only going to factor it out of the x terms. So then you take your coefficient of the x, divide it by 2 and square it. 2 divided by 2 is 1. 1 squared is 1. We call this our magic number. We're going to add that magic number in the parentheses. And I also need to subtract it so that my equation stays balanced. Now that I have added and subtracted that magic number of 1, I'm going to factor inside the parentheses, and it should factor to be a perfect square. X times x is x squared. 1 times 1 is 1, and we need pluses here. So we did get a perfect square of x plus 1 squared. So now that this is in the vertex form, or the standard form as it's sometimes called, I can identify the vertex as negative 1, negative 6. So I have the vertex that way. Another way to get the vertex would be using that vertex formula. Using the vertex formula, A is 1, B is 2, and C is negative 5. So H is negative B over 2A. That's negative 2 over 2 times 1. Negative 2 over 2 is negative 1. Then we're going to find k by plugging that h into our function. We're doing f of negative 1. Negative 1 squared plus 2 times negative 1 minus 5. Negative 1 squared is 1. 2 times negative 1, that's negative 2. I have 1 minus 7, that's negative 6. So you can see we get the same vertex using either method. We've got a vertex of -1, -6. We also want to find the orientation of this parabola. And to find the orientation, we just need to focus on the coefficient of your x squared term, a. Anytime a is positive, you have an orientation that's up. And anytime a is negative, your orientation is down. So here a is 1, so our parabola will open up. Final question is the axis of symmetry. If you look at a picture of a parabola, you get something that is symmetric around the vertex. That vertex is here. So you get a mirror image on either side of that vertex. That vertical line that passes through the vertex, that is your axis of symmetry. So because it passes through the vertex, we can use that x-coordinate of the vertex in the equation of the axis of symmetry. So our axis of symmetry will be x equals -1. That's a vertical line that passes through the vertex. So for this example, we found the vertex to be -1, -6. The parabola opens up and has an axis of symmetry of x equals -1. For this question, we want to write the standard form of the equation of a circle, and the circle is described below. The circle has a center of 0, -2, and it passes through the point -5, 4. So if we want to write the standard form of a circle, we need to know what that looks like. It's x minus h squared plus y minus k squared equals r squared. That hk represents the center of the circle, and r represents the radius. So we're given the center of the circle. We know the values of h and k. So h is 0, k is -2. So our final piece of information that we need to know to write this standard equation of the circle would be the radius. So we need to know what the radius represents. For a circle, the radius is the distance between the center and any point on the circle. Now we were given a point on the circle to be -5, 4. So if we can measure the distance between the center and the point on the circle, that will give us the radius of the circle. Now we do have a distance formula. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So when we calculate the distance, we're going to get the radius. I'll use my center as x1, y1, and I'll use the point as x2, y2. It doesn't matter which one you let be x1, y1, x2, y2. It will work out to be the same distance either way. x2 is -5 minus x1 is 0 squared plus y2 is 4 minus y1 is -2 squared. Then we have the square root of -5 squared. 4 plus 2, that's 6 squared. So that's square root of 25. -5 squared is 25. 6 squared is 36, so we have square root of 61. And I don't think we can break that down anymore. But now we have the radius of the circle, and we can substitute into our standard form. That's going to give x minus 0 squared plus y minus negative 2 squared equals square root of 61 squared. Let's simplify inside the parentheses. X minus 0 is just x, so we have x squared. Y minus negative 2, that's y plus 2 squared. And square root of 61 squared, the square root and the square cancel each other out, and we'll get 61. So we've got the standard form of the circle here. I do want to give you one more way to figure out the radius. So instead of using the distance formula, I can use this standard form. You've got x and y, that's your point on the circle. H and k, that's the center of the circle. And we're going to be able to solve for the radius. So let's see what that would look like. So if we use our standard form, x minus h squared plus y minus k squared equals r squared, and we substitute negative 5 as our x and 4 as our y, that would give negative 5 minus 0 squared plus 4 minus negative 2 squared equals r squared. We've got negative 5 minus 0 is negative 5. 4 minus a negative 2, that's 4 plus 2, which is 6. Negative 5 squared is 25. 6 squared is 36. 25 plus 36 is 61. And then we'll square root both sides. And we get our radius equaling square root of 61. So we get the same radius using the standard form instead of the distance formula. So our final answer, x squared plus y plus 2 squared equals 61. That's the standard form of a circle with center of 0, negative 2, passing through the point negative 5, 4. In this question, it says, how long will it take for an investment to triple if it's compounded continuously at 13%? So when our interest is compounded continuously, we're going to use the formula A equals PE to the RT. The question's phrased how long, and that tells us that time is our missing variable. And it also mentions how long will it take for our money to triple. Tripling is going to tell us the relationship between our principal and our ending amount. P is our principal, our starting amount, and A is our ending amount. So A will equal 3P. We can use this information to solve for our time. So let's write down our formula. We already got it here. A equals PE to the RT. And we're going to substitute in this relationship. A equals 3P. And we're going to substitute this information about the rate. The rate will be 0.13, 13%. So we will have triple our starting amount with a rate of 13%. And this is going to allow us to solve for time. We'll divide both sides by p, get e to the 0.13t equals 3. Now we have an exponential equation. We have 3 equals e to the 0.13t. We'll take the natural log of both sides. The natural log and e cancel each other out. We'll divide both sides by 0.13, and we get t equals natural log of 3 over 0.13. So let's type that in the calculator. Natural log of 3 over 0.13. So it's going to take 8.45 years for our investment to triple. 8.45 years for our investment to triple if we have an interest rate of 13% compounded continuously. On this example, we want to solve the equation 155e to the x minus 2 equals 5. So this is an exponential equation, and the first thing we want to do is isolate the exponential. So the exponential is the exponent and what it's attached to. So let's divide both sides by 155. 155 cancels on the left, and we have e to the x minus 2. And then on the right, we can reduce. 5 goes into 5 one time, and 5 goes into 155 31 times. Now that we have the exponential isolated, you can take the natural log of both sides to cancel out the e. The natural log and e are inverses of each other. So you get x minus 2 on the left. You can solve for x by adding 2 on both sides. And we have our solution of x equals 2 plus natural log of 1 over 31. Let's type that in the calculator. The direction said to round to 4 decimal places. 2 plus natural log of 1 over 31 gives negative 1.43398. So that 4th decimal place is a 9. We look to the right of it, it's an 8. So we're going to round up. 5 and over, we round up. So we have negative 1.4440. Let's just double check that one more time. It should be negative 1.4340. How long in years and months will it take for an investment to double at 13% compounded monthly? Our interest is compounded monthly. That indicates what formula we're going to be using. We're going to use the formula A equals P times 1 plus R over N to the NT. This is our periodic compound interest formula. We want to know how long, so time is our unknown. How long will it take for our investment to double? Doubling means that our ending amount will be double our starting amount. P is our principal, that's our starting amount, and A is our ending amount. And that is at an interest rate of 13%, which we're going to use the decimal version of that, 0.13. And because interest is compounded monthly, the value of N is how often interest is added into the account. It's going to be 12 for monthly. So let's plug these values in to our formula, and that will give 2p equals so as I said, we're plugging into our formula, and we now have 2p equals p times 1 plus 0.13 over 12 to the 12t. So remember, our goal is to solve for that t in the exponent, so we're going to isolate the exponential by dividing by p on both sides. That's 2 equals 1 plus 0.13 over 12 to the 12t. Let's go ahead and put in our calculator at 1 plus 0.13 over 12. 1 plus 0.13 over 12. Well, that's not a very clean number. You can see how the 3's are repeating. So we don't have a terminating decimal here. So the reason why I'm concerned about this is because it might cause some rounding issues later. So I'd much rather keep this in a fraction form if I could. Let's see if we can get a nice fraction out of this. Math convert to fraction. It's not a very nice fraction either, but at least with this fraction you don't have rounding. So let's use that fraction. 1213 over 1200. And what we'll do is we'll go ahead and write down this number, and we're going to see if rounding is an issue at the end. So this is 1.01083. 1.01083. 1.01083. We'll take a look at the end to see if we get any rounding error with this. So we're going to take the natural log of both sides. Natural log on the left, natural log on the right. So what this allows us to do is to use our power rule and bring that power out front. It's natural log of 2 equals 12t natural log of 1213 over 1200. We're going to divide both sides by 12 natural log 1213 over 1200. And we get our solution of t equals natural log of 2 over 12 natural log of 1213 over 1200. Okay, so let's type this in the calculator. Sorry, I'm trying to get the calculator to move a little bit and it won't move. We'll go ahead and type natural log of 2 over, I need parentheses around my whole denominator, 12 natural log 1213, parentheses over, oops, I need a division first, division over 1200. Close parentheses for the log, close parentheses for the denominator. We get 5.36. Now let me type this again using that decimal value. I want to see how far off we are. So that would be natural log of 2 over parentheses 12 natural log of 1.01083, close parenthesis for the log and for the denominator. So we can see you get 2 decimal places that are the same, but the third decimal place is different. So it does cause rounding issues very quickly, but we want to answer the question, and to answer the question, how many years and months will it take for the investment to double? So with our calculator value, we get our time being 5.36. So the 5 is the years, and we're going to use the 0.36 to give us the months. So let's take off the 5. This is now the fractional part of the years. Let's convert that to months. There are 12 months in a year, so that will be 4 months. That'll be 4 months, 5 years, and 4 months. So it'll take 5 years and 4 months. Let's look at that rounding one more time. Okay, so if under normal rounding rules, I would round to 4 months. But in this situation, I need more than 4 months to get enough interest. So I'm going to round up to 5 months. Together, teammates Pedro and Ricky got 2,681 base hits last season. Pedro had 281 more hits than Ricky. How many hits did each player have? So this is an example of an application of a system of equations. As we read through the problem, we're going to be able to create multiple equations from the given information, and then we'll solve that using the method of either substitution or elimination. So this sentence here says, together, teammates Pedro and Ricky got 2,681 base hits. So what I'm going to do is I'm going to let the number of hits that Pedro had be P, and the number of hits that Ricky had be R. Together, meaning that we can add those number of hits together, we'll have 2,681. So P plus R is 2,681. Pedro had 281 more hits than Ricky. Pedro has 281 more hits than Ricky. So we get the equation P equals R plus 281. So this is our system of equations. And I'm going to solve this system with substitution because I already have this P solved for, and I'll substitute it into the first equation. So I have R plus 281 plus R equals 2,681. R plus R is 2R. I'm going to subtract 281 from both sides. That gives me 2R equals 2,400. I'm going to divide by 2. I have R equals 1,200. So Ricky has 1,200 hits. And then I can find out how many hits Pedro has. That's 1,200 plus 281. That's 1,481. So Pedro has 1,481 hits, and Ricky has 1,200 hits. Determine the real solutions to this system of nonlinear equations. Our system is x plus y equals 3, and y equals x squared minus 8x plus 15. We can solve this system with either substitution or elimination. I'll show you with both of them. I'm going to start off with substitution because the system already has a variable solved for. I'm going to substitute this right-hand side in for y in the other equation, and that will give x plus x squared minus 8x plus 15 equals 3. Let's combine like terms, and we have x squared. X minus 8x is negative 7x plus 15 equals 3. I'm going to subtract 3 on both sides to get x squared minus 7x plus 12 equals 0. I can factor. X times x is x squared. 4 times 3 will give me 12. I need them to both be negative to get that negative 7 in the middle. So I have it factored to be x minus 4 times x minus 3 equals 0. Let's set each factor equal to 0. X minus 4 equals 0 gives x equals 4. X minus 3 equals 0 gives x equals 3. And then we can substitute into either equation. I'll substitute into this one here. So if x equals 4, y equals 4 squared minus 8 times 4 plus 15. 4 squared is 16. 8 times 4 is 32. 16 minus 32 will be negative 16. Negative 16 plus 15, that's negative 1. So one of our solutions is 4, negative 1. Then if x is equal to 3, we have 3y equals 3 squared minus 8 times 3 plus 15. 3 squared is 9. 8 times 3 is 24. And let's see, 15 plus 9 is 24, minus 24 is 0. We get a solution of 3, 0 for the second one. We've got our solutions here, and now I'm going to show you how you could do this with the elimination method. Let's write that same example again, and let's try it with the elimination method. So with the elimination method, we want to try to eliminate one of the variables. In this example, we have the y's being like terms in both equations. However, the x's are not. So if we want to use elimination on this example, we have to eliminate the y's. So I'm going to rearrange this. I'm going to subtract x on both sides. And that will make it so that my equations are lined up. I have y equals negative x plus 3 and y equals x squared minus 8x plus 15. Now I have my like terms lined up, my equals lined up, and here on the right hand side I have my x's lined up and my constants lined up. Now I need for there to be opposite signs on these like terms. I'm going to multiply the second equation by, maybe I'll do the first equation. I don't like to have the x squared be negative, so I'll multiply the first equation by negative 1. That's negative y equals x minus 3. The second equation is the same, it hasn't changed. X squared minus 8x plus 15. And now when I add these equations together, the y's will eliminate, giving me 0. And I have x squared minus 7x plus 12. And this is the same equation that I had before. So this equation can be factored to x minus 4 times x minus 3. Get x minus 4 equals 0, x minus 3 equals 0. We get x equals 4 and x equals 3. And this time, let's plug into the other equation. We'll plug into the first equation and get y is equal to negative 4 plus 3. That's negative 1. So we have a solution of 3, negative 1. And y equals negative 3 plus 3 equals 0. And we get a solution of 3, 0. So same, this x was a 4. So we have solutions of 4, negative 1, and 3, 0. Same solutions that we got using the substitution method. So you can see both methods at the same time. And we got the same solution. Here we want to find the solutions to this system of nonlinear equations. We have y equals x squared minus 6x plus 8 and y equals negative x squared plus 2x plus 2. I'll solve this using the substitution method. I already have a variable solved for, so I'll substitute it in for y in the other equation. So this gives x squared minus 6x plus 8 equals negative x squared plus 2x plus 2. I'm going to move all the terms to the same side. So I'll add x squared. I'll subtract 2x and subtract 2. That's going to give 2x squared minus 8x plus 6 equals 0. I'm going to solve this quadratic equation by factoring. Let's factor a 2 out. We get x squared minus 4x plus 3 equals 0. Let's see if we can factor that quadratic more. X times x is x squared. 3 times 1 is 3. We'll have both minuses to get that minus 4 in the middle. So then I can set each factor equal to 0, get x equals 3 and x equals 1. Now let's find the y coordinates by plugging these x's into either equation. We have y equals x is 3, y is equal to 3 squared minus 6 times 3 plus 8. 3 squared is 9. 6 times 3 is 18. 9 minus 8 is negative 9. Negative 9 plus 8 is negative 1. So one of our solutions is 3, negative 1. For the other one, we have x is equal to 1. Y is equal to 1 squared minus 6 times 1 plus 8. 1 squared is 1. 6 times 1 is 6. 1 minus 6 would be negative 5, plus 8 would be 3. So the other solution is 1, 3. We have our two solutions using the substitution method. Thank you for checking out my videos. Have a great day.